Section 6.6 is on the double angle and half angle identities, which if you pull out your Math 112 identity and formula reference sheet, you can see are right here. Double angle identities are called double angles because they're always doubling some angle, which we're calling A here. Half angle identities are always halving, whatever, some angle we're calling A. The first question you might ask is, how exactly do these formulas come about? Start with something like this. Sine of 2a equals 2 sine a cosine a. Well, scroll over here. Doesn't it look a lot like this? Well, let's start with this formula. Now, all you have to do is say, let's pretend a equals b, and substitute into the formula. So instead of a plus b, you have a plus a. Here, these are like terms. They're just in a different order. So if you add them together, you just get 2 sine a cosine a. And that's really all there is to it. You could do the same thing with this version of cosine 2a. Just go over here and say a plus a. So really, these are just special cases of this one if the angles happen to be the same. You notice there are 3 versions of the one for cosine 2a. That's because you can use the Pythagorean identity. You could substitute for sine squared equals 1 minus cosine squared, or vice versa. You end up with one of these 3. Tangent, you end up with just one version. Let's do an example. Example 1, if you know sine of theta equals 3/7, find the exact values of sine of 2 theta and cosine 2 theta. So if you want to find the exact value of this, let's just start with the formula that gives that. Well on our way here, because we have sine of theta is given to us as 3/7. Unfortunately, we don't know cosine theta, so we have to find it. We weren't given any information about what quadrant we were in, so I made the assumption that the cosine of theta would be positive. Now just go to this formula here, and we've got the sine of 2 theta is equal to 2 times 3/7 times 2 root 5 over 7. We end up getting 2 times 3 times 2 is 12 square root 5 over 49. That's all there is to it. Same thing for cosine 2 theta. Just start with the formula. Which formula are you going to use? Well, whichever of these you have the information for. This one just requires us to know the sine of theta, so let's just start with that one. So just put in sine of theta was 3/7, and that's it. You are done. Now, one thing to be really careful of is we know sine of theta is 3/7. Probably the biggest mistake I see on these problems is people put 3/7 in for theta, but we don't know theta. We could find theta on a calculator. You get about 25.4 degrees, but that doesn't help you because then if you do sine of 2 times that, you get 0.774435345, which is not at all the same as 12 root 5 over 49. In fact, that didn't even work out to the same thing on my calculator. So I think I did something wrong here. Okay, that was a pretty minor mistake, but one I probably should have caught in the first place. Similar problem, but here we're going to use the half angle identity, so just start by writing it down. Now just substitute this into the formula. Again, cosine alpha is negative 3/5. We don't actually know the value of alpha. That's what you get here, and again, I don't know if this is going to be plus or minus because I'm not told what quadrant we're in, so use the wording in the problem to help you determine that. But let's go ahead and check this on the calculator the same way we did. First, let's find alpha using inverse cosine. Your recording inexplicably messes up, but luckily you can just start it again and keep going. You get about 0.447. Let's see if this is the same thing. We get about 0.447. So it looks like this answer is right. We just found it exactly by going through the formula.